Hi, my name is Darshan and I'm an online tutor of math and physics. In this video, we'll talk about FRQ4 2023 AP Calculus BC exam. This is one of the easiest question in the complete paper, in the complete exam, except the last part. The last part is a little tricky, but rest are really straightforward. Okay, it's all about interpretation. We have to keep in mind that, okay, let me read out the question. The function f is defined in the closed interval -2 to 8 and satisfies f of 2 is 1. And this graph is not of f, it's of f prime, right? That's what we have to keep in mind. The derivative of f consists of two line segments and a semicircle as shown over here. All right, there are two line segments, one semicircle, fine. Does f have a relative maxima, relative minima or maxima, or neither at 6? Give reason to your answer. Let's ask ourselves before even looking to the graph, when can a function have a relative minima or maxima? When f prime 6 is a 0 or undefined value. In other words, when that x equal to 6 is a critical point, given that f6 exists. So if 6 is a critical point, and very important, f prime x changes its sign. Now here it's very clear that although f prime 6 is definitely 0, I can see that f prime 6 is 0, it's just touching the x-axis. But it's not changing sign, it's just going from positive to positive, right? It's above the x-axis, so it's positive, and before 6, positive after 6, so it's not changing sign. So it's a critical point, but it is neither a max, neither a minimum, nor a maximum, because it's not changing its sign. So we're going to say it's neither, since this is not happening over here, this is not changing its sign. All right, pretty straightforward. Next question, on what open intervals, if any, of the graph is the graph of f concave down? Let's ask ourselves, when is the graph of the function concave down? When its double derivative is negative or less than 0. What is the meaning of this with respect to f prime? If f double prime is negative, don't you think it means that f prime x is decreasing? The other way around will be easy to understand. If a function, let's forget about the primes, if a function is increasing, what is the condition? F prime is positive. If a function is decreasing, what is the condition? F prime is negative, right? So I'm going to write this over here and we're going to draw an analogy. If f prime is positive, it means that the function is increasing. If f prime is negative, it means that the function is decreasing. So if f is a new function, let's say g prime. So if this is g prime, obviously this will be its derivative, which is g double prime. So can we say that if g double prime is negative, g prime is decreasing? And that is exactly what is happening over here. That it's a vice versa. It's going from actually no, it's the same way. If g double prime is negative, so you know the function's double derivative is negative, it means that g prime is decreasing in nature, right? G prime is decreasing in nature. This means that f prime is decreasing in nature, right? And when is f prime decreasing? That's pretty straightforward. Over on this interval, oops, and on this interval. This is where the f prime is decreasing. So the value of x is from -2 to 0 union 4 to 6. If you don't like the union thing, the union way of writing it, or you can write in the inequality form, it's -2 to 0 and 4 to 5. Sorry, 4 to 6. Oops, I wrote 5 over here. There should be 6. 4 to 6. All right, makes sense. Excellent. Let's move ahead. Find the value of this so-called limit or show that it does not exist. Justify your answer. So the best way to find a limit is first we always check that direct substitution is working or not. So I just plug 2 in the function and see what am I getting. So I'm getting 6 times f of 2 minus 3 times 2. What is 3 times 2? 6. That's correct. 2 square, what is 2 square? 4. That's right. What is 5 times 2? That is 10. And plus 6 remains as it is. What is f of 2? I think that's given in the question. There you go. I will highlight. F of 2 is 1. So if f of 2 is 1, this means that I'm going to place f of 2 as 1. 1 times 6 is, yeah, and 6 minus 6 is 0. So, and 6 plus 4 is 10, 10 minus 10 is 0. So that's a 0 over 0, which is an indeterminate form. And remember a very great, very important, very effective rule, let's call it, method which we can use to evaluate the 0 over 0 or infinity over infinity form. That is a L'Hopital's. So I'm going to use L'Hopital over here. What L'Hopital suggests is you find the derivative of the top and the bottom separately till the indeterminate form is ruled out. So I'm going to find the derivative of 6fx first, which is just going to be 6f prime x, and the derivative of 3x is just going to be 3. The derivative of x square is going to be 2x. The derivative of 5x is just going to be 5. And the derivative of 6 is just going to be 0. And now I'm going to sub in 2 and let's see if we are getting a meaningful answer. So it's 6 times f prime 2 minus 3 over 2 times 2 is 4 and 4 minus 5 is negative 1. So I'm going to get negative 1 over here. What is f prime 2? That's very easy. I have the graph, entire graph of f prime in front of me. And f prime of 2, where is 2? 2 is here. So f prime 2 is 0. 0 times 6 is, yeah, 0. 0 minus 3 is minus 3. Minus 3 over negative 1 is 3, because both negative and negative will just cancel. So negative 3 over negative 1 is just 3, which is the final answer of this question. I think this is the last part, yes. What is the absolute minimum? Okay, so this is a little challenging. There is a long way to solve this question as well, which some people have done. But I'm going to tell you a really conceptual way in which you can, just by analyzing the curve, it's a more analytical than doing more work, but it's a perfectly legit method. Find the absolute minimum of f in the closed interval of negative 2 to 8. Okay. Can we highlight the intervals where f prime is positive? So f prime is positive here, f prime is positive here, and f prime is also positive over here. Okay. Can we mark the critical points? The critical points are negative 1. The critical points are, another critical point is 2 and another critical point is 6. We already know that at 6 we have neither max nor min. So this is the neither case. At negative 1, I have the f prime changing from positive to negative. So that's the relative max. And at 2, it is changing from negative to positive. So that's going to be relative min. I'm interested in absolute min. So obviously, absolute min would be at the points either of local min or relative min or the extremas. So the relative max and neither are just ruled out. It cannot happen at these points. And then at the terminal. So terminal is just either negative 2 or it should be 8. All right. Now, the yellow part are the parts where f prime is positive. And what happens to f if f prime is positive? F prime is positive. Don't you think it means that f is increasing in nature? Okay. I'm going to draw a rough sketch of function f. I do not know from where it starts. I have no idea from where it starts. Let's say it starts somewhere from here. And I'm going to draw it from negative 2. I'm going to draw it from negative 2. Negative. I do not know from where it starts. Maybe it starts from here. It's not going to change our answer. So I know that the yellow part is where the function is increasing, correct? I don't know how the function is increasing. Maybe in a straight line, maybe in a curve. I don't really care. but we can figure it out, but it's not required. Maybe the function is increasing and it becomes still -1. It is increasing and maybe it becomes something like this. Okay, all right. Now the green portions are where the function is decreasing continuously, because the f prime is negative, right? F prime is negative, and whenever the f prime is negative, we very well know that the function decreases. So if f prime is less than 0, the function is going to decrease over there. So from -1, the function is going to take a detour and gonna go down and down. Obviously there will be a smooth turn over here because the derivative exists. So it's gonna be a smooth turn and the function just decreases, going down, maybe somewhere till 0.2. I do not know how down it goes, I don't really care, but maybe somewhere at 2 it stops. Now again is the yellow region. So for the complete entire duration, the function keeps on increasing. Maybe it increases like this, maybe it increases just for this portion, I don't care. Maybe it increases like this and ends over here. But what I care about is they need the minimum value. Don't you think the minimum value is actually at -2? Because that is the only point till which the function is decreasing. Till rest all the points, for all the duration, in fact the complete duration, remaining duration, the function is increasing. It cannot be minimum or lower than 2. So the answer is f of 2 without even finding anything. It's already given in the question that the value of f of 2 is 1. So its absolute minimum is 1. So its absolute minimum is 1. Absolute minimum is equal to 1 without doing all that antiderivatives or definite integrals, right? This is a perfectly valid method. I hope you understand this. Let me know if you have any confusion. I would be more than happy to clarify more in the comment section. And if you found this video helpful, please subscribe to my channel. Bye-bye.